Hi everyone and welcome in this Python course for absolute beginners. My name is Yassen Dimitri Signé. I'm a civil engineer and I will be your instructor in this Python course for beginners. This is a part 1 and I'm working for the part 2. So this is the program of all what we are going to see in this part 1. Install Python and IDE, variables, operation of variables, list, dictionaries, input function, if statement, loop, while loop, and function. I hope you are going to enjoy this course, and if it is interesting, encourage my work by liking this video and sharing with your friends. Python is an open source programming language. To install it, you have to go to the browser and you type python.org. Once you are on the official website of Python, you can go to Windows if you are using Windows operating system, and you take what corresponds to your computer. In this case, I will take 64-base executable installer. After, I will open and just execute it. It is very important to activate this add python to path, and we are going to see why later. So I chosen, I install, I say yes. Now that the setup was successful, I can close it. You can write Python code in the terminal, but the problem is that it will be very boring. There are something that is called IDE, which means Integrated Development Environment, which help you to write Python code in an aesthetic way. One of the most popular IDE for Python is pycharm. So I'm going to show you how to install pycharm. So you just have to type pycharm, then you go on the official site of pycharm. So when I'm on the official website of pycharm, I can download the free version, which is this one. I click download and I download the free version that we are going to use in this tutorial. When the download is completed, I can open the file and I can execute it. Very simple. I say yes. I just say next. I want to add the launcher to the path, so you can take this and you just say next, install. When the installation is finished, I click on finish. Now I can go here and open pycharm. Do not import setting. I click OK. I confirm, continue or not. I can skip the remaining to default. And now I can create a new pycharm project. I will put this name, hello world. Create. So I can close this. Now I can set the font of my scripture in the code. So I go to File, I go to Settings, then I go to Font. In Editor I go to Font, then I can increase the font size here. I can put, for example, 25, and this is a preview of how my code will look. So I can tick OK. I come back here in the project, I come on the folder on the left, I right click and I say new Python file. I call it hello world project. It will be our very first Python project, and I press enter. So you see up here it has created a new Python file. In Python there are many built-in functions that you don't have to code them from scratch. Now I want to show you one of the most used built-in function, which is the print function. It allows you to display anything on your screen. Print, I put double quote, hello world. I will explain you in the next tutorial why we put this double quote. But first of all, let's run this and see the output. So I go up here on run and I choose this run. I choose the project hello world, and you see in the terminal it is printed hello world. Now I can close this terminal and I can erase this. So I can close this left panel by clicking here on the project. Awesome. I want to introduce a new concept, which is a very basic concept in Python about variables. In fact, a variable is a reserved memory location to store a value. It's quite similar to variable in mathematics. For example, I can say x, and to x I assign the value 1. So if I use my print function, I will say print x. If I run it, the output is 1. This means that I've assigned the value 1 to the variable x. So in the memory, the value 1 is stored in the x variable. Now, if after I say again x is equal to 2, if I run it again, I will now have the value of x is no more 1, but it is 2 here in the terminal. This means that Python runs code line by line. So on the first line it assigns the value of 1 to the x variable, and at the second line it substitutes the value of 1 by 2. So when I print on the third line, the new value of x is no more 1, but it is 2, as you can see here in the terminal. So every variable has what is called a data type. For example, this x I've assigned the value 2, which is an integer. So the type of variable x is integer. I can print the data type of x by using the function, the built-in function type. So if I write in lowercase type of x and I close the parentheses for print function, if I run it again, I will have int, meaning that the type of the variable x is integer, because the value which is assigned to that variable is an integer, which is 2. Another data type is floating point number. For example, if I create another variable y, and if I assign the value, for example, of 1.5, and if I print the type of y, I run the code, I will see here in the terminal float, meaning floating point. Another type is what we call string. If, for example, I say I create a variable called my name, so is equal to, we can define a character sequence, so we must put a double quote, and I can print, for example, my name Yacinthe. So this is just a character sequence called a string. So if I say here print the type of name, if I print it, I will have str, which stands for string. These are the three most basic data type that you need to know to get started with Python. There are many other data type in Python. We are going to see them later. My aim in this course is to let you understand Python in a very basic and simple way. So we are first of all going to understand how these three data types, that is integer, floating point, and string, works. And as we are going to proceed in this course, I will show you the other data type, and I will explain you in which situation you have to use each of them. Now I want to show you some operation on variables. So for addition, it's just like in mathematics, a plus sign. Subtraction, the same as in mathematics, multiplication, a star. Division and power. Those operations are mostly used for integers and float. So let's go back in our Hello World project, and if this is x and y, let's define or declare another variable which is set is equal, for example, to x plus let's say plus y. So if you want to print the value of z, we type here z, and we expect to have x plus y, which is 2 plus 10, which will give 12. So let's run and see what is the result. So you see it's exactly 12. So you can do addition between number type, float, or integers. I can also do a division, and if I print again, I will have 0.2, which is 2 divided by 10. If I do a minus subtraction, I will have minus 8, which is 2 minus 10. And if I multiply with a star, I am expecting to have 20. So this is the result, 2 multiplied by 10, which is x times y. And now if I add a star, it will be a power. So it is 2 power 10. If I print again the result, it's 1024. Data type. There is one operation which is very important, which is called concatenation. Imagine this situation where I have my name, which is in this case my first name, and I want to write my second name. So my second name, for example, I will say Sin. Now I want to show you that it is also possible to write a string with a single quote instead of a double quote. So this is another way to write it. I will write, for example, my second name. Now if I create another variable called my full name, I can say that my full name is my first name, and I concatenate with my second name. So if I print my full name, I will get the result Hyacinthe Signé. Concatenation has created from two different string values, one string value which is my full name Hyacinthe Signé. Notice how I declare this variable second name. I cannot leave an empty space like this between second and name. So when I declare a variable, I cannot leave an empty space like this. I must always put an underscore. In Python, when you want to define a comment, that's a line that Python will not read it or will not interpret it, you have to put the hash character. So this is it, and I can put any comment. Now consider the situation where instead of just printing my full name, I want to say good morning, my name is. So in this case, I want to say good morning, my name is, and then I return my name. So this comment is just to help me to understand my code. When you have a code with 1,000 or many rows, it is sometimes important to write a comment to explain what's the idea behind your code, to easily understand it when you will improve it in the future. Coming back to our example, if I want to print this thing, I can just come here in print and say I put the double quote and I print good morning, my name is. Now here I will put maybe Signé Hyacinthe, but the problem is that anytime that I will print it, I will always have good morning, my name is Signé Hyacinthe. If I print it again, you see I will still have the same thing. But what if I want to say good morning, my name is, and I take any name that the user has provided and I put it here and print it in the terminal? So in order to do this, I'm obliged to use something, and this is a new concept I'm introducing. It is called formatted string. So in order to create a formatted string, you have to put an F before. Instead of putting my name here, I will instead put a variable. So before I put a curly braces, and in this curly braces I will put my name. So that is it. With this syntax, anytime that I want to print this, Python will say good morning, my name, and we return here the name given by the user. So this is a way to dynamically render a string. So if I print again, I will have good morning, my name is Hyacinthe Signé. But if I change my name here and I put maybe, let's say Dimitri, if I print again, you see it says good morning, my name is Hyacinthe Dimitri. So you can change as you want and put anything. You will see that every time that you print, it dynamically render the new value of the name. So this is very important for strings. Now I want to introduce a concept which is widely used in Python. It's about list. So list object type is a collection of other types. So it can be a collection of string that we have already seen, integers, floats, or list again. It can also be a collection of other data type that we are going to see later in this course. Going back in my Hello World project, if I want to declare a list, I just have to give his name. For example, I will declare my list and I put a square bracket. So this is how we declare a list in Python. But now it is an empty list because nothing is inside, but I can fill it with different data type as we have seen earlier, which are strings, float, list themselves, or any other data type. To keep it simple, we are just going to fill with integers. So I put, for example, 1, and to put the next value I put a comma and I put a space so that my code will be beautiful. I put 2, I put a space, 3, 4, and maybe let's say 5. If I print this list, print my list. So if I run, you see the list has been printed. As you can imagine, lists in Python are much more powerful than just printing them in the terminal. There are many types of operations that we can perform with list. I will show you some of the commonly used operations. For example, if I want to add another number here at the end, maybe I want to add 6, I will use append, what we call a method. So I will use an append method. Method is something related to object-oriented programming. We are going to see it later in this course. I can say my list, and to access that method I must put a dot, and you see there are different methods that are presented that I can perform on the list. So for example, if I take the very first, which is append, now you see this parenthesis, it is asking what is called an argument. If I put, for example, 6 and I print my list again, the new list, you see the value of 6 has been added. I can also use the remove method. So now I can put what I want to remove. For example, if I want to remove the value of 4, so I just have to put here 4. And so if I print the result, I will have the list but with the value of 4 removed. If I want to find the position of a number in my list, I will use instead the index method. So for example, the number 3 is here at the 0, 1, and 2, so at the second position. Notice that in Python, numbers start at 0, not at 1. So when I count, I start at 0 here. So the number 1 is at 0 position in the list. Number 2 is at the first position, so at position 1, and number 3 is at position 2. So if I want to have the position, I will use the index of 3. And if I instead print this, I will cut it and paste here in the print function, and this is what I get too, because number 3 is at the position 2, as I said. On the same way, if I print, for example, the position of number 5, so position of number 5, and in that list number 5 is at position 4. On the other hand, if I want to do the opposite, that is, I know the index of a number and I want to know that number in the list, so I will instead use this syntax, my list, and I will use square bracket, and I will put the value of the index here in the square bracket. For example, if I say 0, that is, I want the very first value in the list. I can put that value in a variable called, let's say, z. If I print the value of z, I'm expecting to have 1 because the first value in my list is 1. So I'm expecting to have printed in the terminal 1. Let's run and see. So it's exactly what we said. If for example I say I want the number in the list at the position 1, I'm expecting to have the value of 2 because 2 is at position 1 in the list. So let's print and see. So that is it, I have 2. As you have guessed, programming is not just printing values in terminal. When I get a value from the list, I can do a multiple type of operation with it. I can, for example, define another variable that I will call maybe y, and I can say that y is equals to 2 multiply by, for example, let's say z. So what is my code saying? It says that go in my list, take the number which is at position 1, assign it to the variable z, and then create another variable y and multiply that z value that you have got from my list by 2. So if I print the value of y, I will get 4 because this is 2, please, this is 2 and this is 2, so the value is 4. 5 is the last value of my list. A way to select the value 5 is to say 0 1 2 3 4, so it's to put his index here, which is 4. But there is another way to select the last value of a list, which is using the -1 index. So -1 index is the index used to select the last value of a list. If I do this, the value of z will be 5 and y will be 2 times 5 will be 10. So let's print and see if it's correct. So you see that is the value we got. Now let's erase this. Imagine the situation where I want to know the number of elements that my list has. So I will use the length function. It is like this, len, and I put the bracket and I put the name of my list, which is my list. If I print, I will have the number of elements that are in my list, which is 5 elements. Here is a point. Notice the color of print and len. They have the same color. That's the color used by default in pycharm to differentiate built-in functions. As I told you, there are functions that come with Python. You don't have to program them from scratch. And they are also reserved word. So you cannot create a variable called len because it is already a reserved word. Or you cannot create a variable called print because it is a reserved word. Now, imagine a situation where I want to select a subset of this list. Let's say, for example, I want to select number 2 to 4. So I can create another list. I will call it, for example, sub list, and it is equal to my list. And now I want element going from 1 2 to 3. So I will put in the square bracket, I want elements from 1, I put 2 point, and now I put 4. So what does it mean? It means that I will have element 1 to 4 minus 1, which means I will have element 1 2 3. So let's print this sub list and let's see the result in the terminal. So we print and you see it gives 2 3 and 4, which is this range. Another object data type widely used in Python is dictionary. In fact, a dictionary is generally referred as mapping. So mapping are also collection of other objects just like list. But the difference is that they store object by their key instead of relative position. In fact, mappings don't maintain any reliable left to right order like list, but they simply map keys to associated values, just like dictionary in a real world. In a real world dictionaries, you have words which are keys and their associated values are their definition. So it's the same concept in Python programming with keys and values. Let's go back in our Hello World project and see how we declare a dictionary in Python. To declare a dictionary, I must declare his name just like other variables. So I can say my dictionary and I assign the value. Then I must put a curly braces. So imagine the situation where I want to describe somebody. I want to give his name, his age, and his height. So my dictionary is going to have 3 keywords. The first keyword is name. Since name is a string, I must put either a double quote or a single quote. Let's use a single quote in this case. So name, and I put 2 points like a description, and I put the name. For example, another string, I can say Sin, that's my name, and I can put the second keyword, which is the height. Don't forget to put double quote. So I cut this and I paste here. I put 2 points, maybe 1 meter point 75. Notice that the height here is a float data type. Now I can also put the age. So I put age, let's say 25. If here is an integer. Now notice this red underlining my code. It is saying that there is an error in my code, and this is why pycharm is beautiful, because when you write something that the computer don't understand, you have something like this that tells you that there is something wrong. pycharm used to tell me that, hey, I don't understand what you are writing. In this case, it's just because we have not put a comma to separate each keyword and values. So we must put always a comma to separate, so that pycharm will understand that the name key has as value Sin. Then we go to the second one, which is height as key, and the value is 1.75, just like we define in list. So I put a comma and a comma, so the error has disappeared. Beautiful. In the list data type object, when we wanted to get the value, we use indexed, but in dictionary, as I said, we instead use the keywords. So if, for example, I want to have my name, I will create, for example, another variable called my name, and my name is, I will go in this dictionary and I will take the value with keyword name. So I come here, I write in my dictionary, and I put square brackets just like in list, but now I instead put the key, which is name. Don't forget to put the double quote because it is a string data type. Now if I want to print my name in the terminal, my name, and I print, you see it has returned Sin. which is the value of this key name. This is a very simple dictionary. Imagine the case where instead of just giving one name, I want to give my first name and my last name. One way of doing this could be to have a keyword for first name and have another keyword for last name. But I want to show you a more powerful way and aesthetic way to do this in Python. It's a concept I want to introduce. It's about Python object nesting. So instead of just giving the value here, I will give as value to name another dictionary which will have my first name and my last name. I erase this value and I will paste instead another dictionary with my first name and the value I put, for example, let's say Yacent, and comma to separate, you remember, and then my second name or my last name, the value is, let's say, sin. So I put 2 points and remember it's a string, so sin. Let's look at the code to understand what it does. If I print again my name with keyword name, the value will be all of this before the comma. So I'll have another list. Let's print it and see. I'll have another dictionary, please. So let's print and see. You see, the value of name now is no more a string, but it is a dictionary. It means that if I want to get only my first name, I must say that go in the keyword name, it gives me another dictionary, and me only the first name. So I will put another square braces, and here I will put a string, that is this key, which is first name. I copy and I paste. So if I print it again, now I will have only my first name, which is Yacent, because my name will go in keyword name, it will return a list, a dictionary, please, and in that dictionary it will return the value with keyword first name, which is Yacent. Let's print and see the result. So you see, that is Yacent. A dictionary can also contain a list data type object. Imagine that I want to add, for example, another key here to give the profession of the person. So I add a key profession. I will just put prof and 2 point. Now somebody can have many professions. I will take 2 examples, engineer and scientist. So I create a list with 2 string value with engineer and scientist. So if I want to get the profession, as we said, the keyword profession, I put it here and I erase this. Beautiful. So if I print again, let's call this variable profession, and this is profession. Close the parenthesis. Beautiful. And if we print this profession, the value will be this list. Let's print and see. So it's returned the list of professions. Now what if I want only to select the engineer in this list? I will not use a keyword in this case because I have a list. So remember, when we have list, we instead use index to select values in the list. So if I want to select engineer, it's at index 0 in this list. So I put index 0, and if I print again, I'll have just engineer or scientist. It is at index 1, so if I print again, I'll have scientist only as the value of my variable proof. I'm trying my best as possible to keep this course very simple to show you that Python is a beautiful programming language. So if you enjoy what I'm doing, please encourage my work by liking the video and sharing with your friends. Until this point, we have declared our variables and directly assigned value to them. Imagine a situation where we want to build a real software where it will ask values from the user and use those values to computations. In that case, we must use another type of built-in function, which is the input function. For example, let's imagine a program that asks to a user his country and print that country in the terminal. So I will create a variable called your country and I will assign a value, but I will not directly give the value here. As I said, I want the user who use my program to give his country and the program print his country in the terminal. So I'm introducing here the input function. So input, and I will ask a question to the user. Remember, it's a string when you want to write a character sequence. So I write, what is your country? Question mark. If I print this in the terminal, so I will come here and print your country. So let's run this and see what it gives. So when we run, the program asks me, what is your country? So I can answer, for example, Cameroon. And if I press enter, you see the program return Cameroon. So the program print my country, Cameroon. In order for you to see this very well, I can print a complete statement like my country is, and dynamically render my country name. So you remember, I must put these curly braces and this variable my country, I cut it and I paste here. Very good. And remember, I must close the string. Good. And now don't forget to put an F before, because it is a formatting string. So when I print, you see it asks me again, what's your country? And if I write Cameroon again, when I press enter, it writes my country is Cameroon. So every time that I will change please the value of my country, will dynamically print my country. So this is a very important built-in function input to ask from a user the value of a variable to perform some calculation with it. There is a very important thing on which I want to draw your attention. Let's, instead of asking the country, let's ask maybe the age of the user, which will be now a number. So what's your age? And we dynamically want to render his age. So we put here your age. If we run it, what's your age? I put, for example, 25 again, and I press enter. Beautiful. It gives the same result, but the point where I want to draw your attention, instead of printing your age, let's print the type of variable your age. So we erase this and we write the type, the type of your age, and we close the print function. Beautiful, and we run it again. So what's your age? If I give 25 again, you see the type, it is not integer but it is a string. Why? Since I gave 25, but why is Python saying that it is a string? It's because input function always return values in the string data type. It means that with this value I cannot directly do calculation that are valid on number types like integers and float. For example, let's define the age of the user in 5 years. So the program is asking his name and we return his name is in 5 years. So let's create a new variable and we call it age 5, which means his age in 5 years. It's equal to your age, his actual age. So in 5 years he will be his actual age plus 5. But if we print this, we have an error because this is not an integer or a float. So this is a string. You cannot do the sum of a string type and a number. So if we print, you will see that error. Let's print and we put the age 25, and if we press enter, you see we have what is called a type error. I'm going to show you how to manage errors in the future, but from now I just want you to read this. Can only concatenate string, not int to string. It's because, as I told you, input function, although I've put 25, return that 25 not like an integer but like a string. So Python here understand that I want to concatenate this string with an integer, which is impossible. So if I want to get the input from the user and I want to do some calculation, I must convert it either in integer or float. For example, let's convert this age to integer. So to convert, this is a new built-in function that I want to show you. We must use int. This is to convert to integer, so lowercase int, and I put the bracket parenthesis. Good. Now if I print, I will have 25, which is this plus 5, so I will have 30 years. So let's, for example, cut this and we paste here, and we take the age, we paste here. Very good. So if I print now, what's your age? I say now 25, and if I press enter, it gives me 20. The error has disappeared because I've converted the age to integer. If I instead want to convert to float, I must use the built-in function float. It's always in lowercase, float. And if I print again, it will convert this value to float and add 5. So I print, what's your name, what's your age, 25, and enter. So it gives me 30.0, which is a float number. Now I want to introduce a new topic on statements. Statements are the thing you write to tell Python what your programs should do. Let's start with the easiest and most common statement, the if statement. Imagine a situation where, for a student, for example, we want to ask his mark, and when he gives us his mark, the computer or our program, with respect to the value of his mark, if it is equal to 10, then the program says you exactly have the average. If his mark is not exactly equal to 10, so that is else the program says you don't have the average. So let's go back in our hello world project. Let's erase this. Beautiful. So the first thing is to ask the student mark from the user. So we are going to use, as you know, the input function. Let's declare our variable mark is equals. Let's declare our variable mark, it's equal to the input function, and we ask to the user, what is your mark? So we put a question mark. When he gives us his mark, we must convert it. You remember, we must convert it in a float or in an integer. In this case, we are going to convert it in a float, so we are directly going to convert it here. We close the parentheses. That's very good. So it means that every time that the user will provide his name, the function float will convert it to a float, and we are going to do some calculation if we want with the value. Now, when we already have the mark of the student, we must say that if, so this is the statement, the syntax of the if function. If you see the color, that is the color used by pycharm by default to show the keyword for statements. So if the mark given is equal, now notice the difference between this and this equal. This first value here, mark, is not an equal, but I'm just assigning value, but here it is equal. It means that this value is exactly the same as the value on the other side, that is 10. So if mark is 10, then the then in Python it is 2 point. So this is the syntax to declare a if statement. This is how we read it. If mark is equal to 10, then you see it is exactly like English language or any other language. That's why Python is beautiful, because as you think your code, you can write it directly like that without any other computation. Enter. Notice this indent. The indentation is related to the fact that in Python, to show that all the sequence of calculation below will be done only if this is true. So Python must in statement put an indent, and this it is equal to 4 space. Imagine that I am there, and if I want to do the same indent, I must press tab 1 2 3 4, or another way is to directly press the tab and the indent is automatically done. So if the mark is equal to 10, I want to print you have the average. Now if it is not true, that is if the mark is not 10, if it is different, I will say else. You see 2 point, else you print you don't have the average. Average. Now look at this. I told you that when pycharm underlines my code, it means that there is a problem. Now here, what is the problem? I'm defining a string, and as I told you, I can define a string with single quote or double quote. In this case, I've decided to define the string with single quote, but the problem is that I want to write you don't, and when I write don't, there is this quote, and Python understand it as is the end of the string that I've started here. So in order to overcome this situation, I must instead use double quotes like this and like this. I remove this. Beautiful. Now I can put this single quote and Python understand now that it is a string because outside it is double quote. Let's run the code and see how it works. So the code asks what's your mark. If I say 10 and I press enter, the code writes you have the average because I've given 10, so mark is equal to 10. That's why it gives me you have the average. But if I run again and what's your mark, if I give something different from 10, maybe let's say 11, and if I press enter, you see it says you don't have the average because the mark is not 10, so he has done the else part of the statement, which is this: you don't have the average. This is a simple case of statement of if statement where we have only two possibilities: either you have the average or you don't have the average. Now imagine that I'm in a case where we have many possibilities. Imagine the case where when I have the mark of the student, if the mark is less than 10, I say you don't have the average. If the mark is equal to 10, I will say you have exactly the average. And if it is greater than 10, I say you are above the average. So in that case, you see I have three possibilities. So to manage a case where we have many possibilities, we use an intermediate elif statement. So if mark is equal to 10, you have the average, good. I will use now elif. It is always in lower letter. Elif. Now mark is lower than 10, then I must insert print you are under the average. And the third situation is if the mark is greater than 10, so I don't need to specify that case. That's the else part. You don't have the average, or you are above the average. I erase this. Beautiful. So if I run it again, what's your mark? If I say for example 10 again, it says you have the average because it is equal to 10. Now if I run and again, what's your mark? If I say for example 5, because 5 is less than 10, I will have this message please printed you are under the average. So if I run, you are under the average because the value is less. And if I give a value greater than 10, for example 12, you are above the average. So when I have more than two possibilities in a statement, the all other intermediate possibilities, I write them with the elif. So I have in the if statement the if ones which start the statement and the else at the end for the closure of the statement. So it means that if I have maybe 10 other condition, I will use the elif function. Please, I will use instead the elif to specify all those other. The other category of statement is loop. Loops are statements that repeat an action over and over. Let's start with the for loop. So the for loop is designed for stepping through the items in a sequence object and running a block of code for each. For illustration purpose, let's for example compute a function f of x is equal to x squared plus 2. So let's try to compute this f of x function with the value of x given. So we are going to define a list called y is equal to f of x, and the value of x will be stored in a list also called x. So we are going to have two lists, a first list with the values of x and a second list that is going to store the different values or result of the computation of f of x. Let's go back in our hello world project. We erase this. So we define a list. We define a list x is equal to, you remember, square bracket, and I can put some values inside, maybe 2 3 4, I don't know, anything. I have defined a list. Let's define now the list where the different values of y will be stored. So we say y lower y is equal to an empty list. This is how we declare an empty list. Now I want to take each number here, I compute x squared plus 2, and I append in this list. So one way of doing this is to take 2, square it, plus 1, and I append. Then I take 4, I square it, plus 2, and I append. So you see that doing it for all the list will be boring. Imagine the case where we have a list with thousands or millions of elements. It will be very impossible to take each item and perform the same computation. So that's why for loop is very powerful. So this is how we use a for loop to solve this problem. It's just like the if statement. So I say for anything, I can say item in x. So for anything, for something in x, x is the list where I want to take the different item. I put 2 point, then I press enter, and you remember the 4 indentation for statements is there. I say item, or I define another variable that I can call as I want. Maybe f is equal to the item multiply or square, so its power. I press start twice, 2 plus 2. So that is it. It means that for each item in this my list, if we take that item, square it, and add 2, it's exactly our function of f of x is equal to x squared plus 2. And after, when he has computed the value of f, it must take the y list, and you remember, append the value of f. So at the end, I press enter, and I go back to say that my loop is finished. So I'm no more in my loop because you see there is no more indent. So these are only the 2 lines that are in my loop. After, I want my program to print the new value of the list y, which is the result of f of x. So let's run the code and see the result. You see, Here I have 6. In fact, 6 is 2 square, which is 4, plus 2, it is 6. Now 4 square, it is 16, plus 2, it is 18. So you see that with only 1, 2, 3 lines of code, I've computed this very quickly and in a simple way. And if I increase again numbers here, with this number that I've added, if I run again, you see for all the list, it has computed the different value of x squared plus 2. So even if I have 1,000 of elements in this list, with just these 3 lines of code, I can do the job. You understand why the for loop is very important when we want to repeat the same block of code on different items. Now imagine a situation where I have some negative values in my list. So let's add some negative values. I'm just adding like that for illustration. And we don't want again this x squared plus 2, but we want to have in the y values only the positive values which are in this list. When we are doing this will be, as I said, to come here and look, this 4 positive, 9 is positive, and we append. But it will be boring when we have many elements in the list. So we can use a for loop again to solve this problem. But the for loop is not enough, because there is a condition. We want to select number, but numbers which are positive. So that is the application of the if statement. So I can come here and I say for item in x, if the item that is selected is greater than 0, so to y I must append that value. So I must append the item and I can print y again. So my code is saying that, okay, you come in this x list, you take the first value which is -2. Now you test whether it is positive or not. If it is positive, you append. It means that if it is not positive, you will not append. So this is the way that we are going to select only the positive values in this list. So let's print and see the output. So you see it has printed the y which is having only the positive values. It's the same if we say give us only the negative values. So if we print again, we have only the negative values. So for loop is very important when you want to do the same block of code on different elements in a sequence. The other type of loop that I would like to show you is the while loop. The while loop repeatedly executes a block of code, normally indented statement, as long as a test at the top keep evaluating to a true value. This is very literal. Let me show you how it works with the same example as we use in the case of for loop. So let's again solve this problem of calculating x squared plus 2 with a while loop. But the difference here is that we should consider a situation where we don't have a predefined x list, because when we were in the for loop, we had a predefined x loop and we were just computing the value of x squared with x squared plus 2 with the values in x. Now consider the case where we want to automatically generate the list of x from 0 to 20 and compute also automatically x squared plus 2. So let's go back in our hello world project and let's erase this for loop. Beautiful. Now let's erase also all the element in this list, because we said that we don't want to have a predefined list. We erase all. In this case, X list and Y list are both empty. So I want to fill X list with value from 0, for example, to 20, and automatically compute X squared for each value inside plus 2. So this is how we define a while loop. We first of all give the what we call initialization. So we say I, for example, equals to 0. So this is the very first value that will come here in X. We say that while this value of I is less than 20, because we want to fill X with value from 0 to 20. So while this value of I is less than 20, we should add or append this value of I in this list. So while I is less than 20, 2 point to X, you append I. Now look what's going to happen. The while loop will start here at 0. It will take 0, and 0 is less than 20, so it's going to append 0 to X. Now you don't know what it's going to do after, so after we should increment the value to 1. So we are going to say to I is equal to the previous value of I plus 1. So now when it takes 0, it tests 0 is less than 20. Yes, it's true. So it append the value 0 here to X, and it comes here, it says 0 plus 1. I now is equal to 1. It comes back here, it tests 1 is less than 20. Yes, and it append is to X, and so on until this value or this condition is false and it stops. So another aesthetic way to write this incrementation is to directly write I is equal plus equal, and we put 1 here. I go out of my loop, and if I print the value of X and I run the code, now I run it, if I run the code now, you see the list has been filled with values from 0 to 19, because I is less than 20. The last value is 19. Now I don't just want to fill the X list, but I directly want to compute X squared plus 2 like in the previous case. So when you append the value, you also directly compute the F value, which was equals to I square, so star twice plus 2, and this value of F, you are going to append it to Y. Now if I print also let's use the curly braces to print dynamically the result. So let's say X is, and then we put the curly braces, we cut this and we paste, we put the end of the list with single quote, and we put the F for formatted string. We copy this and we do the same for y is, and if we print it, you see we have x is, we have the different values of x, and then y is, we have those values, but we have the same values because we have, instead of appending f, we have appended I. Let's append instead f because f is the value of the function. So if we print again, so you see we have the different value of x and y, different values of y. So this is 0 square plus 2, it is 2, 1 square plus 2, it is 3, and so on. Let's see a new topic about function. A function is a device that groups a set of statements so they can be run more than once in a program. So imagine that you have a part of your code that you want to use in your program several times. Instead of copying that part of program every time and pasting, you should maximize the code reuse and minimize redundancy. So that's why you can create a function so that every time that you want to perform that set of calculation, you just call that function. Functions are also useful for procedural decomposition. Imagine you want to teach your robot to cook a food. You have to tell him a set of instructions how to wash, for example, the cooking pot, another set of instructions how to put the cooking pot on fire, is another set of instructions how to prepare your meal, and another set of instructions on how to serve the food, and so on. So you can divide all of this procedure of cooking a food in different functions at different steps. It makes your code more structured. Until this point, we have already seen what we were calling built-in function. The type of built-in functions that we have seen were the print function that allowed us to print the result in the terminal, the input function that allows us to ask from the user an input in order to perform calculation, the float that was helping us to convert a string to a float type, and the int that was helping us to convert an integer, that was helping us to convert a string to an integer. There are many other type of built-in functions that come with Python, but imagine that you are writing your code and you want to write your own functions. So that's what we are going to see in this section. The example we are going to use in this case for illustration of the importance of function is how to solve a quadratic equation, which is ax squared plus bx plus c equals to 0. Let's go in our Hello World project and we erase. Now we know that to solve a quadratic equation we need the coefficient a, b, and c. So I must define those coefficients. Let's say a is equal to 1, b is equal to 2, and for example c is equal to -1. So this is quadratic equation we want to solve. Now we know that to solve a quadratic equation we must compute the discriminant, that is generally called in mathematics delta. So I will say delta is equal to b squared minus 4 times a times c. So that's the formula to compute the discriminant. So we know that with this, the first solution is x1 is equal to, I put the parentheses, b minus square root of delta, so it's delta power 0.5 divided by parentheses 2 times a, 2 times a. So that's the solution of, and this I copy and I paste. So x2 is equal to b. Those are the two solutions we have in the second degree quadratic equations, but we don't always have these two solutions. It depends on the value of delta. We know that if delta is greater than 0, that's when we have these two solutions. So we understand that we must put here a if statement. So if delta is greater than 0, 2 point, so notice that I have x which is underlined as red. You remember, it means that there is a problem. What's the problem? The indentation. So I must press tab. I press tab again, so my code is indent. Beautiful. If the discriminant is equal to 0, so I will put another condition, if delta is equal to 0, then I have only one solution, so x1 is equal to b divided by parentheses 2 times a. So that's when I have only delta equals to 0. Else, that is when delta is negative. I don't have any solution, so print no solution, no solution. Before we run the code, let us in this case say you should print the result. So print, we are going to use formatted string to dynamically render the value though. So I say f like formatting string, and I say x1 is equal to, I put my curly braces and I put x1. We paste it and we change x to x2. Okay, very good. The same thing here, we paste x2 and x2, that is instead x1 and x1. So now let's print and see first of all the result. So you see the values are, we are in the first case, the values are x1 minus 0 and 0.4 and x2 2.4. Imagine now that I want to solve the same equation with different values of a, b and c, but I don't want to lose this result, so I want to know the result of this bunch of values a, b and c, and I want maybe to compare with another values of a, b and c. So you understand that I will be obliged in that case to copy all this code, to copy it, and I will paste it here for example, and I will come here, and maybe if I want to change the value of b, I can say maybe b equals to 3, maybe a equals to 2, and if I print again, I will have x1 and x2 for the first equation, and I will have x1 and x2 for the second equation. So now if I want to do this 10 times, I will be obliged to copy the code 10 times, so I will be duplicating the code. That's not good at all in programming. That's where function come in. If I write this with a function very well, every time that I would like to solve again a second degree equation, I will just call that function and solve it without copying the code. So let's see how it works. Let's first of all delete this. So I erase this till here. Good. Now I will show you how I will structure this code so that I can reuse it later. To create a function, I must use the keyword def. Then I put the name of the function. I can put any name that I want. For example, I can put solve equation. So I can put this, I put parentheses, and I put 2 point. Good. Now in these parentheses, I must put what we call in Python variables. It's quite similar as in mathematics when you define a function of f of x where x is the variable, but in this case we call them the parameters. So the parameters will be a, b, and c. So I put here a, b, and c. This delta must also be in the function, so I cut it and I paste it in the function. So notice that I have a red everywhere here. It means that I have a problem, you remember, and the problem is, maybe you have already guessed, is because I haven't indented my function, because I haven't indented my code. So in order to indent, I select it all and I press tab. Beautiful. Now I can erase this a, b, and c. I can erase it all and go back up. Very good. So this is how I've created a function that generalizes the solution of a second degree equation. Every time that I would like now to solve a second degree equation anywhere in my program, I will no more copy all of these and paste again, no, but I will just call this function and it will solve for me. So let's, for example, solve, let's copy this, and we want, for example, to say equation 1 is equal to, we paste, so the value of a, let's say as the previous example, is 1, the value of b is 2, and the value of c is -1. If we call that function on these 3 parameters a, b, and c, and if we print, now that we have defined our function, we are not going to print directly the result, but we are going to say that it should return, this is a new word, return the value of x1 and the value of x2. The same thing here, it should return the value of x1, and if we are in the last case, it should print no solution. So let's try with this equation 1. So let's say at this point it should print equation 1, and let's run the code. So you see I have here the value of 0.41 just like in the previous case, and 2.41. Now what is very interesting with the function is that if I want to solve another equation, let's say equation 2, I will not have to copy the code as we did before, but I will just call again the solve equation, and I will just put the values of a, let's say for example a equals to 2, b equals to 3, and maybe c equals again to -1. And if I print now equation 1 and equation 2, I run the code, you see I have the solution for the first equation and solution for the second equation, and I can play with numbers. Again, I can change, I can put equation 3, or you see it's very interesting. You can put maybe -2 here, and you say print equation. I copy, I paste. Python is so funny, that's why I love Python. So you put equation 3 and you print again, you have the 3 solutions. So it's very interesting of using function in your program in order to structure it in a aesthetic and good way. I will be very glad if you tell me in comment box below why you want to learn Python programming language. I'm planning to do the second part of this Python basics with more advanced topics. So if you like what I'm doing and you want to encourage me, please just like the video and share it with others. Ciao.